Scaffolding, also called staging, is a temporary structure used to support people and material in the construction or repair of buildings and other structures. Scaffolding has been used since ancient times. There are many kinds of prefabricated, modular system of metal pipes or tubes, although it can be custom-made from other materials such as wood and bamboo, which is frequently used in Southeast Asia. History. Antiquity. Sockets in the walls around the Paleolithic cave paintings at Lisor suggest that a scaffold system was used for painting the ceiling, over 17,000 years ago. The Berlin Foundry Cup depicts scaffolding in ancient Greece. The ancient Egyptians, Nubians and Chinese are also recorded as having used scaffolding-like structures to build tall buildings. Early scaffolding was made of wood and secured with rope knots. Modern era. During the Victorian era, scaffolding was put up by individual firms with wildly varying standards and sizes. Scaffolding was rationalised by the British Patent Rapid Company, founded in 1906 by Daniel Palmer Jones and his brother David. In 1919 and is now owned by Harsco. Palmer Jones patented the Scafixer, a coupling device far more robust than rope which revolutionised scaffolding construction. In 1913, his company was commissioned for the reconstruction of Buckingham Palace, during which his Scafixer gained much publicity. Palmer Jones followed this up with the improved universal coupler in 1919, this soon became the industry standard coupling and has remained so to this day. In 1923, the company introduced tubular steel water pipes with standardized dimensions, allowing for the industrial interchangeability of parts and improving the structural stability of the scaffold. The use of diagonal bracings also helped to improve stability, especially on tall buildings. The first frame system was brought to market by the firm in 1944 and was used extensively for the post-war reconstruction. Scaffolding today. The European standard, BSEN 12811-1, specifies performance requirements and methods of structural and general design for access and working scaffolds. Requirements given off for scaffold structures that rely on the adjacent structures for stability. In general, these requirements also apply to other types of working scaffolds. The purpose of a working scaffold is to provide a safe place of work with safe access suitable for the work being done. The European standard sets out performance requirements for working scaffolds. These are substantially independent of the materials of which the scaffold is made. The standard is intended to be used as the basis for inquiry and design. Materials. The basic components of scaffolding are tubes, couplers and boards. The basic lightweight tube scaffolding that became the standard and revolutionized scaffolding, becoming the baseline for decades, was invented and marketed in the mid-1950s. With one basic 24-pound unit, a scaffold of various sizes and heights could be assembled easily by a couple of laborers without the nuts or bolts previously needed. Tubes are usually made either of steel or aluminium, although there is composite scaffolding, which uses filament wound tubes of glass fiber and a nylon or polyester matrix. Because of the high cost of composite tube, it is usually only used when there is a risk from overhead electric cables that cannot be isolated. If steel, they are either black or galvanized. The tubes come in a variety of lengths and a standard diameter of 48.3 The chief difference between the two types of metal tubes is the lower weight of aluminium tubes. However, they are more flexible and have a lower resistance to stress. Tubes are generally bought in 6.3 lengths and can then be cut down to certain typical sizes. Most large companies will brand their tubes with their name and address in order to deter theft. Boards provide a working surface for scaffold users. They are seasoned wood and come in three thicknesses, 50 and 63 are a standard width and are a maximum of 3.9 meters long. The board ends are protected either by metal plates called hoop irons or sometimes nail plates, which often have the company name stamped into them. Timber scaffold boards in the UK should comply with the requirements of BS 2482. As well as timber, steel or aluminium decking is used, as well as laminate boards. In addition to the boards for the working platform, there are sole boards which are placed beneath the scaffolding if the surface is soft or otherwise suspect, although ordinary boards can also be used. Another solution, called a scaff pad, is made from a rubber base with a base plate molded inside. These are desirable for use on uneven ground since they adapt, whereas cell boards may split and have to be replaced. Couplers are the fittings which hold the tubes together. The most common are called scaffold couplers, and there are three basic types: right-angle couplers, put-log couplers and swivel couplers. To join tubes end-to-end joint pins or sleeve couplers are used. Only right-angle couplers and swivel couplers can be used to fix tube in a load-bearing connection. Single couplers are not load-bearing couplers and have no design capacity. Other common scaffolding components include base plates, ladders, ropes, anchor ties, reveal ties, gin wheels, sheeting, etc. Most companies will adopt a specific color to paint the scaffolding with, in order that quick visual identification can be made in case of theft. All components that are made from metal can be painted, but items that are wooden should never be painted as this could hide defects. Despite the metric measurements given, many scaffolders measure tubes and boards in imperial units, with tubes from 21 feet down and boards from 13 ft down. Bamboo scaffolding is widely used in Hong Kong, with nylon straps tied into knots as couplers. In India, bamboo or other wooden scaffolding is also mostly used, with poles being lashed together using ropes made from coconut hair. Basic scaffolding: the key elements of a scaffold are standards, ledgers and transoms. The standards, also called uprights, are the vertical tubes that transfer the entire mass of the structure to the ground where they rest on a square base plate to spread the load. The base plate has a shank in its center to hold the tube and is sometimes pinned to a cell board. Ledgers are horizontal tubes which connect between the standards. Transoms rest upon the ledgers at right angles. Main transoms are placed next to the standards. They hold the standards in place and provide support for boards. Intermediate transoms are those placed between the main transoms to provide extra support for boards. In Canada this style is referred to as English. American has the transoms attached to the standards and is used less but has certain advantages in some situations. Since scaffolding is a physical structure, it is possible to go in and come out of scaffolding. As well as the tubes at right angles, there are cross braces to increase rigidity. These are placed diagonally from ledger to ledger, next to the standards to which they are fitted. If the braces are fitted to the ledgers, they are called ledger braces. To limit sway, a facade brace is fitted to the face of the scaffold every 30 meters or so at an angle of 35°-55° running right from the base to the top of the scaffold and fixed at every level. Of the couplers previously mentioned, right-angle couplers join ledgers or transoms to standards, put-log or single couplers join board-bearing transoms to ledgers, non-board-bearing transoms should be fixed using a right-angle coupler. Swivel couplers are to connect tubes at any other angle. The actual joints are staggered to avoid occurring at the same level in neighboring standards. The spacings of the basic elements in the scaffold are fairly standard. For a general-purpose scaffold the maximum bay length is 2.1 meters, for heavier work the bay size is reduced to 2 or even 1.8 m, while for inspection a bay width of up to 2.7 m is allowed. The scaffolding width is determined by the width of the boards. The minimum width allowed is 600 m, but a more typical 4-board scaffold would be 870 m wide from standard to standard. More heavy-duty scaffolding can require 5, 6 or even up to 8 boards width. Often an inside board is added to reduce the gap between the inner standard and the structure. The lift height, the spacing between ledgers, is 2 m, although the base lift can be up to 2.7 m. The diagram above also shows a kicker lift, which is just 150 m or so above the ground. Transom spacing is determined by the thickness of the boards supported. 38 m boards require a transom spacing of no more than 1.2 m, while a 50 m board can stand a transom spacing of 2.6 m, and 63 m boards can have a maximum span of 3.25 m. The minimum overhang for all boards is 50 m and the maximum overhang is no more than 4x the thickness of the board. Foundations. Good foundations are essential. Often scaffold frameworks will require more than simple base plates to safely carry and spread the load. Scaffolding can be used without base plates on concrete or similar hard surfaces, although base plates are always recommended. For surfaces like pavements or tarmac, base plates are necessary. For softer or more doubtful surfaces, sole boards must be used. Beneath a single standard, a sole board should be at least 1000 µm squared with no dimension less than 220 mm. The thickness must be at least 35 mm. For heavier duty scaffold, much more substantial balks set in concrete can be required. On uneven ground, steps must be cut for the base plates. A minimum step size of around 450 mm is recommended. A working platform requires certain other elements to be safe. They must be close-boarded, have double guardrails and toe and stop boards. Safe and secure access must also be provided. Ties. Scaffolds are only rarely independent structures. To provide stability for a scaffolding framework, ties are generally fixed to the adjacent building steelwork. General practice is to attach a tie every 4 m on alternate lifts. Prefabricated systems scaffolds require structural connections at all frames, EA 2-3 m centers. The ties are coupled to the scaffold as close to the junction of standard and ledger as possible. Due to recent regulation changes, scaffolding ties must support plus/slash loads and lateral loads. Due to the different nature of structures, there is a variety of different ties to take advantage of the opportunities. Through ties are put through structure openings such as windows. A vertical inside tube crossing the opening is attached to the scaffold by a transom, and a crossing horizontal tube on the outside called a bridle tube. The gaps between the tubes and the structure surfaces are packed or wedged with timber sections to ensure a solid fit. Box ties are used to attach the scaffold to suitable pillars or comparable features. 2 additional transoms are put across from the lift on each side of the feature and are joined on both sides with shorter tubes called tie tubes. When a complete box tie is impossible, a L-shaped lip tie can be used to hook the scaffold to the structure. To limit inward movement, an additional transom, a butt transom, is placed hard against the outside face of the structure. Sometimes it is possible to use anchor ties. These are ties fitted into holes drilled in the structure. A common type is a ring bolt with an expanding wedge which is then tied to a node point. The least invasive tie is a reveal tie. These use an opening in the structure but use a tube wedged horizontally in the opening. The reveal tube is usually held in place by a reveal screw pin and protective packing at either end. A transom tie tube links the reveal tube to the scaffold. Reveal ties are not well regarded, they rely solely on friction and need regular checking, so it is not recommended that more than half of all ties be reveal ties. If it is not possible to use a safe number of ties, rakers can be used. These are single tubes attached to a ledger extending out from the scaffold at an angle of less than 75 degrees and securely founded. A transom at the base then completes a triangle back to the base of the main scaffold. Specialty scaffolding. Types of scaffolding covered by the Occupational Health and Safety Administration in the United States include the following categories: pole, tube and cupola, fabricated frame, Plastiursa Euro 1 registered trademark, Decoratorsa Euro 1 registered trademark, and large area scaffolds. Bricklayers, horse, form scaffolds and Carpenter's Euro 1 registered trademark. Bracket scaffolds, roof brackets, outrigger, pump jacks, ladder jacks, window jacks, crawling boards, step, platform, and trestle ladder scaffolds. Single-point adjustable suspension, two-point adjustable suspension, multi-point adjustable suspension. Stonesetters Euro 1 registered trademark multi-point adjustable suspension scaffolds, and Masonsa Euro 1 registered trademark multi-point adjustable suspension scaffolds. Catenary, float, interior hung, needle beam, multi-level suspended, mobile, repair bracket scaffolds, and stilts. Gallery of scaffold types. Put-log scaffold. In addition to the put-log cupolas, there are also put-log tubes. These have a flattened end or have been fitted with a blade. This feature allows the end of the tube to be inserted into or rest upon the brickwork of the structure. A put-log scaffold may also be called a bricklayer's scaffold. As such, the scaffold consists only of a single row of standards with a single ledger. The port logs are transoms, attached to the ledger at one end but integrated into the bricks at the other. Spacing is the same on a port log scaffold as on a general-purpose scaffold, and ties are still required. In recent years a number of new innovations have meant an increased scope of use for scaffolding, such as ladder beams for spanning spaces that cannot accommodate standards and the increased use of sheeting and structure to create temporary roofs. Pump jack. A pump jack is a type of portable scaffolding system. The scaffold rests on supports attached to two or more vertical posts. The user raises the scaffolding by pumping the foot pedals on the supports, like an automobile jack. For U.S. requirements and guidelines on pump jacks including a diagram see the U.S. Department of Labor website. Baker staging. Baker staging is a metal scaffold which is easy to assemble. Rolling platforms typically 29 inches wide by 6 feet long and 6 feet tall sections which can be stacked up to 3 high with the use of added outriggers. The work platform height is adjustable. X-deck ladder scaffolding, low-level scaffolding that is height adjustable. It is a hybrid ladder scaffold work platform. Standards. The widespread use of scaffolding systems, along with the profound importance that they earned in modern applications such as civil engineering projects and temporary structures, led to the definition of a series of standards covering a vast number of specific issues involving scaffolding. Among the standards there are, DIN 4420, a DIN standard divided in 5 parts which covers the design and detail of scaffolds, ladder scaffolds, safety requirements and standard types, materials, components, dimensions and load-bearing capacity. DIN 4421, a DIN standard which covers the analysis, design and construction of falsework, 29 CF a Part 1926, safety standards for scaffolds used in the construction industry from the U.S. Occupational Safety and Health Administration, with an accompanying construction e-tool. See also, National Access and Scaffolding Confederation, Willow Island Disaster, References. External links. Illustrated Formwork and Temporary Work Glossary, New York City Scaffolding Regulations PDF, OSHA Publication 3150. A Guide to Scaffold Use in the Construction Industry, OSHA Scaffold Types Illustrated, illustrations of many kinds of scaffolding.